work now on implementing the T-cell display function, but in a recursive manner. So we are now in the linky_recursive.c file. The T-cell display function is here. Let's go back to the iterative version, and we're going to cut and paste just to give us a starting point. Okay. So we select the code here, copy, go back to the recursive version, and paste it right here. Okay, there we go. We have a starting point. Okay. So now, what is the difference between recursive and iterative? Recursive means that we essentially replace loops by calls to the function itself. Okay, this is what we saw in Fibonacci numbers, what we saw in factorial, the factorial example of recursive function in one of the earlier modules. So let's review here what we did already and see what we can keep. If my parameter is null, I don't have the address of a pointer, I don't work. If star list is null, this is an empty list, I don't have to display anything. Other than that, I need to display the current element, then move to the next one, and keep doing that until p is equal to null. So here is the deal. Instead of using p here, maybe we can get rid of it. Our condition, our termination condition is when p is null, I am done. What is p? P is star list, right? It was initialized to star list. When star list is null, I am done. So it seems that on line 11, we already have something that is going to make a stop when this function is called on the address of a pointer referring null. So that's good. That's going to be our termination condition. Other than that, what do we need to do? Well, if we are here, we display simply the value of the current element. Okay? And once we are done doing that, we go to the next element. So we are going to do a recursive call, T-cell display, and I need here to pass the address of a pointer to the next element of the linked list. That's what's going to cause the recursion. T-cell display, when called on with the address of a pointer on the first element, will display the data in that first element. Then it will call itself with the address of a pointer on the second element of the linked list and display the data in that element, and so on and so forth. Where do we have a pointer on the next element of the linked list? Inside of star list, a row next. And it's really important right now that you take a sheet of paper and you draw a diagram of what is going on at each steps of those functions. Okay, before to work on any function involving linked list processing, you need absolutely to make diagrams on paper and understand what it is that you want to do. Once you understand what you want to do in terms of moving your rows around and stuff like that, then you can move on to implement it. Let's take an example on how we can come up with what we just coded here. So here's our little sheet of paper here. Okay, what do we have here? Well, we are going to try to represent simply but accurately what's going on. Inside the main, I have a local variable list, right? This local variable is a pointer to one or more element of type T-cell. So this is going to be a first T-cell with a data value, let's say 0, and a pointer next, which is going to point to maybe a second element with its own data, let's say 1, and a pointer next, which is going to be null, indicating that this is the last element of the linked list. In our T-cell display function, what do we have? Well, we have a parameter list. Don't be confused by the fact that it has the same name as the function in the main. This parameter list is a pointer on element of type T-cell. When you call T-cell display the first time from the test.c main function, you will pass the address of the list variable in main, which makes this pointer here, the list parameter in T-cell display, point to the list local variable in main, which points to one or more element in the linked list. So back to our code. Back to our code here, we are trying to figure out how I can access the address of the next element in the list. You can waste a lot of time trying to just figure it out, without a diagram. If you look at a diagram, you are here, and you want to find the address of this element here. It's just a game of follow the arrow. You need to access first this pointer. How do you access it? Access it from list, star list. This is star list. Once you are on star list, you realize that this is a pointer on a structure, which means you can access the field of that structure with the arrow notation. Which field would you be interested in? Next, because it contains what? The address of the next element in the linked list. So you see how first making a diagram of the situation, second change color and try to make a diagram of what you want to access, what you want to do, and then going to the code makes it considerably easier than trying to figure out things directly from the code. So star list arrow next is actually a pointer which contains the address of the next element of my linked list. Well, let me put parentheses for caution around this. If I take the address of that, I'm calling tCellDisplay with the address of a pointer referring to the second element of the list. Once I'm there, I will check, is this address of pointer null? Well, if everything goes well, if next exists, it will never be null. So I'm just detecting an error here, but it won't occur in this scenario. Is star list null? If star list is null, that means next here contain null, which means I'm done with my job. Otherwise, display the element and call yourself recursively on the next element. The last thing we need to fix here, we were using p. Let's revert back to the notation based on star list. Okay, now let's save this function. And you see how when you are using self-referential data structure, a recursive solution generally tends to be easier to read once you get used to it than a regular solution. Let's compile here recursive. Let's execute our recursive function. We have now the same result that we had with the iterative. We can display the list, okay? We don't add to the front, add to the tail, etc. So it's incomplete still, but we can see the result at least of displaying the list right here.